Assalamualaikum and every good day everyone. Today we will explain about our project on miniature fountain using ideal gas law. Before that, let me introduce myself. My name is Nurhanisa binti Zulkifli and another my two group mate is Nur Fatina Diha and Nur Ain Shahida Izzati. Did you know the same principle that power turbine and irrigation system can be demonstrated as simple as using bottle, water and straw? Let's dive into the thermodynamic principle on miniature fountain. For the first part, I will explain to you all about the background of the prototype and thermodynamic principle applied for the prototype. The miniature fountain prototype demonstrates the thermodynamic principle focusing on the pressure, temperature, and fluid dynamics. This is essential in industry where managing in temperature and pressure is crucial for efficient operation. For example, in agriculture, pressure-based irrigation system use pump or gravity to create high pressure in the main pipes. When water flows through the sprinkler head or drip emitters, the pressure drops, then allowing controlled irrigation. Next example is oil and gas. Pressure differences are used in processes like gas lifting and oil wells and hydrocarbon separation during refining. The third example is energy production. Turbine and boilers convert heat to the mechanical and electrical energy by using fluid like steam. Heat increases the fluid's pressure and temperature, driving motion to produce power. Next, I will explain to you all about the concept of thermodynamic principle that apply in the prototype. The prototype is using ideal gas law, which is PV is equal to nRT, which describe the relationship between temperature, pressure, volume, and amount of gases. I will explain one by one about the concept that involve. The first one is, in the prototype, when the bottle is heated, the air molecule inside absorb energy, causing them to move rapidly and collide more frequently with the walls of the bottle, which in turn increases the internal pressure. Sealing the bottle traps this heated air, preventing it from expanding. Then, submerging the bottle in cold water creates a temperature difference that amplifies the pressure differential between the inside and the outside of the bottle. This pressure differential forces the water in the external container of the straw as the higher internal pressure push is upward, attempting to balance the internal and external of the pressure. However, as the air inside the bottle cools, its temperature and pressure decreases, which causes the fountain effect to stop. This cooling reduction and pressure process reflect how temperature and pressure are regulated in industrial system where controlling this factor influence overall system performance.
Next, I will continue with problem statement. The miniature fountain was designed based on ideal gas law principle, which is in educational way to show how thermodynamics work. For this project, recycled material is used, such as glass bottle and straw, to make it affordable and environmentally friendly. Even though the idea is simple, but there are some issues to think about it. First, for the cost of equipment. If we apply in industry, the cost for a project must be expensive. However, using the recycled material helps to reduce the cost and leads to an environmentally friendly approach. Next, size of the equipment must be designed with a compact system, and recycled components demand creativity to ensure the material functionality and strong, so that it doesn't leak when the project was started. Then, for the efficiency, recycled material may have a pressure loss that can make prototype less effective and might not always handle pressure perfectly. Since ideal gas law is used in this project, the principle is main key to make this fountain works, and without it, the fountain might not perform as expected. For example, calculation in improper way could break or waste the energy. By applying this principle, the prototype achieves a balance of cost effectiveness, works well, and eco-friendly by showing how thermodynamics and creativity concept can work together to solve problems and make something cool.
Next, we move to the next part, which is supplementary problem that related to the prototype. A miniature fountain system is constructed using 0.5-liter glass bottle as the pressure vessel. The system works by heating the air inside the bottle, creating a pressure difference that drives the water through a straw to simulate a fountain effect. The bottle is initially at room temperature, which is 25 degrees Celsius, and atmospheric pressure, which is 100 kPa, and it is sealed tightly. For the first question is determine the pressure inside the bottle after it's heated to 80 degrees Celsius. Assume the volume of the bottle remains constant and the amount of air inside does not change. The second question is, if the bottle is cooled back to 20 degrees Celsius, calculate the pressure inside the bottle. Discuss how the pressure change relates to the cessation of the fountain effect. So, let's solve the problem. The first one is, determine the pressure inside the bottle after it is heated to 80 degrees Celsius. Assume the volume of the bottle remains constant and the amount of air inside does not change. The first one, we use ideal gas law. N is constant volume, which is isochoric. P1 is equal to 100 kPa. T1 is equal to 25 degree. We convert into Kelvin, we got 298 Kelvin. And T2 is 80 degree. We convert to Kelvin, we got 353 Kelvin. We rearrange the equation, we got 180.46 kPa. So, the second question is, if the bottle cooled back to 20 degree, evaluate the pressure inside the bottle. Discuss how this pressure change relates to the cessation of the fountain effect. What is cessation? Cessation means end of stopping water from rising up. When it cooled back to 20 degree, we assume ST3. We convert to Kelvin, which is 293 Kelvin. P1 is equal to 100 kPa, T1 is equal to 198 Kelvin, and T3 is 20, and we convert to Kelvin, 293 Kelvin. Why is cooled to 20 degree? It represents the surrounding ambient temperature. It demonstrates how the system naturally returns to equilibrium state with its environment. Industrial systems often cool back to ambient temperature for efficiency and safety. This makes the prototype realistic and show how thermodynamic processes work in real-life system.
Design of thermodynamic miniature water fountain. First, material required. We use transparent glass bottle act as the air and water container. Second is plastic basin, which is to hold cold water for cooling. Third is modified bottle cap with a hole for the straw. Actually, we use a clay. And fourth, we use plastic or silicone straw to allow the water flow. Fifth, we use color powder, which is optional just for the visual. Second is setup step. Fill the plastic basin with the cold water and add color powder. Second, seal the glass bottle with a clay and insert the straw through the hole. Third is turn the bottle upside down and place it in the cold water in the basin. Third step is working principle. The cold water cools the air inside the bottle and lowering the air pressure. The pressure difference push the water up through the straw and creating the water fountain effect. So the conclusion is the miniature fountain prototype shows how thermodynamics principles, like the ideal gas law, work in a simple and fun way. It demonstrates how temperature and pressure interact to move fluids, which is useful in industries like energy and irrigation. Using recycled materials makes the project affordable and eco-friendly. It also helping to protect the environment. With proper design and calculations, the fountain works safely and effectively. This project combines science and creativity to solve problems while keeping costs low and promoting sustainability.